So a few quick notes on soil. As you read, and as you see on the top of your worksheet, soils are made of a number of things besides just the eroded minerals. And when you look at this, when you look at the picture, it starts with the sea horizon, which seems maybe kind of backwards, but the sea horizon, so it's showing you how the soil forms. You saw in the Tim and Moby, the bedrock is actually just the rock. It is not weathered at all. Nothing can grow in it. As that slowly starts eroding, you get the sea horizon. As you see here, the sea horizon forms as bedrock weathers and rock breaks up into particles. It is poor soil. It is not able to grow very many things, but it is starting to break down from solid rock into some sort of soil. And so then as the soil continues to erode, next you have the A horizon, which again might seem a little bit counterintuitive. We start with C, then we go to A. The A is known as the top soil. The A is on top. The A horizon develops as plants add organic material. So plants, as we talked about yesterday, plants can do some chemical weathering and also some mechanical weathering as they break things down. So the A horizon, you get some living things. You get living things like somebody mentioned worms. You get plants. You get lichens. Somebody yesterday talking about, Moab was talking about the cryptobiotic soil, which is bacteria and fungi and things like that. And it's very fragile, but it's the first thing that is breaking down rock into smaller pieces. So in the poorest, most simple soil would be the sea horizon. And then as it gets a little bit better quality of soil, you get the A horizon. So now you get more organic or things made from life into the soil. And then finally, again, as I mentioned in the video, when areas have been around for a very long time, you get the B horizon. And so you've got rainwater washing clay and minerals down from the surface. You get a lot of living things, the more living things. And then as you mentioned, every season, whatever they die, so you've got dead leaves, dead grass, those decay. You get bacteria and fungi and worms and such decaying that. And so up on top, you get a very rich A horizon. The A horizon gets better and better. And now you have a B horizon. So now there's a layer in between the C horizon and the A horizon. So the richest soils not only have more rich stuff in the A horizon, but you also have a layer in between. So trees can have deeper roots. And you got more layers of plants, more things growing. So there are the three horizons. Questions about this? All right, let's go on to the next slide. Not like the super detailed thing, but just in case you might wonder, soil particle size. We all know what clay is like. We have a lot of clay in the soils around here. We have something that's called bentonite clay. When it gets really wet and muddy, and then you're walking around, and pretty soon your shoes are, 4 inches thick with mud. It's very, very sticky. That's bentonite clay. And when you look at this, the reason it's so sticky is it has very, very, very tiny particles. 1/256th of a millimeter, to be exact. But it makes a very sticky, fine clay. This can be a problem around here because they call them expansive soils. When they have a lot of water in them, somewhat like a sponge, they're bigger. And if there's not a lot of water, they shrink. This causes a problem if you build your house on it when it's very dry or even when it's wet, and then you have drier years and wetter years, the soil expands and contracts and cracks the foundations. And this is actually a big problem around here because we have a lot of those clays, but people build houses and shopping malls and stuff on the soils anyways. And if it cracks the foundation, cracks the walls, the building might have to be torn down. So we definitely have that. And then sand, again, pretty obvious. Everyone knows what sand looks like. You can actually see the particles. And gravel. and then silt is kind of in between. But just to give you a sense for the different properties of the soils that you probably never thought of before. Well, yeah, it's not life-sized, of course. Um, then soils also are different depending on the different things in the soils. Again, I'm not going to read through all of this, but you can see that different types of soils. Around here, tundra soils do not occur everywhere in the world. But if you go up to Rocky Mountain National Park, places like that, we do have tundra soils. It's very harsh. They do not get a lot of rainwater, not a lot of soil. Northern forests, so Pacific Northwest, the Northeast, obviously very rich soils. Prairies, that's where most of our farmland happens. We have mountain soils. Topsoil is thin. Cold temperatures slow the weathering. Yesterday we talked about things that affect the rates of weathering. Desert soils, you might guess, few plants, sand, and then tropical soils, some of the richest. That looks like pretty much the same thing. So you can see some of the different soils in the United States. And I believe that's, oh, so here, and again, soil is not just dirt, but soil also includes the living things. So it's the minerals, it's the decaying stuff, and when we talk about weathering, you've got all this living stuff that's contributing to the soil. You've got roots that are growing in here, you've got insects, you've got burrowing animals, you've got fungi, you've got all sorts of stuff going on here. And you can see here the C horizon, you've got your rock fragments, you've got your topsoil on the top, the A horizon, and the in-between B stuff. And this just says every cubic meter of soil contains billions of organisms. All right. Billions. All right. So, questions about soil or questions about anything on your worksheet?